All right, here we go. We're going to talk about what each one of these words mean. We've been using the word power. The power means it is a product of repeated factors. You have your vocabulary things. Did you, on the one that we had already started, is it full? The one that you already had in your binder?
We didn't have it.
This is the very first?
Yeah.
Oh, I thought 6th graders already did it.
Yeah.
Hang on, I'll know. You're right. I don't think we've had any other vocabulary words. You're welcome. Okay, so this is our first vocabulary words. Okay, so you have your graphic organizer. Now I gotta get me one because this is. No, wait, I'm filling mine out too. And we're gonna, now you've got your notes page. And we're gonna kick over to right here. In the center of your page, you're gonna write the word power. In the center of my organizer, I've got the word power. Thank you. Have fun. Do you at least get to eat something other than school food while you're gone? There you go. That would be bonus. Okay. What is the definition of the word power? It's on your notes that you have right there in front of you. Some of you.
Repeated.
Mr. Brian.
Product of repeated factors.
Okay. So it's a product of repeated factors. All right. Now that's a definition. That's a mathematical definition, isn't it? Mathematician might say that, right?
Yes.
What could you give in additional facts that would make sense to you? Something else that makes sense to you.
Oh.
What do you think,
How many?
Kagan?
How many numbers there are? Like, how many threes there are? How many twos?
Maybe. Do you always just automatically know what product is?
Yeah.
Really?
No.
No, I think the word is probably no. And so, do you think maybe I could say repeated multiplication? Could I say that? Would that help me to remember I'm going to repeat multiplying? I could even say multiply the same number over and over again. That might be another way to put it, but I need to know that I'm talking multiplying, okay? All right, let's give an example. Well, you have in your notes, there's an example there. And I believe it's this one, right? Is that what your example is?
Yeah.
Okay. And I'm going to make a note to myself just so I know that that means 3 times 3 times 3 times 3. Now do I know that this whole thing, and I've got to make a note with this example, that right there is the power. Okay? The whole thing is the power. I'm dealing with powers. Now, what's a math? You could write, tell me a math, something I could write, it has to be math, that wouldn't be an example of that. Isaiah, tell me something in math that I could write that's not going to be an example of a power.
2 + 2.
There you go, sir. He's absolutely right. Because the minute I threw that addition in there, it's not a power, is it? We're not dealing with powers. Because powers are always multiplication. Pretty good example right there. Okay? Now, we're going to go back and we're not done with this, so don't take it and put it too far. Now we'll go ahead. Another one of our words, according to our note page, that we need to make sure we know for this particular unit. If you're looking at your notes, and somewhere did I have any extras of those, Mrs. Heston, of the notes?
Oh, no, not of the notes. We had to make a
Okay.
copy.
Yeah, I think I didn't make enough. Okay, no, I'll be fine.
Okay.
We have the word base. Base. And we're not talking about third base. We're not talking baseball. Okay? A base of a power is the repeated factor. A base of a power is a repeated factor. Yeah, that's a really nice mathematical term. Mathematical description of it. We need to make it where we understand. We need to make a note. How do I understand what was just written there? How do I remember what that means? That's kind of a technical definition, isn't it? It is. So, Connor, what does that really mean to you? If we look back at what our powers were, what can I do here to help me know exactly what we're talking about? Okay. Well, sometimes we get lost on factor. Am I correct?
Yes.
We have factors and dividends and divisors and see, I got so many terms in my head they don't even all come out. Okay, so what if we simplified that and said the number that is multiplied by itself. Let's see. Tell me. You know what I'm trying to say? The number that we multiply again and again. What could I say? The number multiplied by itself lots of times. Well, it could be lots of times. The number multiplied repeating. That way we know it's more than once or twice maybe. Does that make more sense? A factor is that number. Okay, so we're going to go back up to that example of 3 to the 4th. Which one of those is the base? What number is the base in the power 3 to the 4th? Which number is the base? Which number is the base? Alexis.
The 3.
Okay. So I'm going to do this, and I'm going to say base. Okay? That way I know that's my base because 3 times 3 times 3 times 3. Okay? I'm showing why, because that kind of goes with the additional facts, doesn't it? Is this an example using that additional facts?
Yes.
Sure it is. The base is always the one on the bottom, written the normal way. Okay? Give me a non-example, not a math example, a non-one. Yes, ma'am.
7 plus 6.
7 plus 6. It's not an example. That's true.
That is true.
Okay? We've done powers. We've done base. What do you call that number that's superscript, that's up there? What do we call that number? Exponent, all right? So guess what? We need a vocabulary one written for exponent. Okay? Exponent. Okay, so now I need to know, what is an exponent? What is the exponent of a power? Gauge. Gabe?
The exponent of a power is the number of times the base is used as a factor.
Okay. So the exponent of a power is the number of times the base is used as a factor. Okay. The number of times, or it indicates the number okay. Indicates or tells you, that's pretty simple, how many times you multiply a number by itself. Because that's really what you're doing, right? Multiplying a number by itself. And that exponent tells you how many times you do it. So if I go down here in that same example, 3 to the 4th, which one of those is my exponent? Which one's the exponent, Miss Myers? I can even use my highlighter, and I'm going to highlight that baby and say, make a little note to self, exponent. Okay. I know what it is now. And I know that exponent tells me to take the 3 by itself, multiply it by itself 4 times. That doesn't say 3 times 4, which is what kids do. It says do 3 times 3 again and again. Okay? Give me a non-example. Yeah, you guys are liking these non-examples. We're getting a lot of people involved in that one. Give me a non-example. Somebody that I haven't heard from today. Amelia. 1 plus 1 works for me. It's not an example. Non-example, 1 plus 1. Okay? Got one more word, and while we're doing them, we might as well answer it. Everybody has that, right?
Yeah.
Perfect square. We're going to define a perfect square. Does anybody know what I'm talking about when I use the word perfect square?
No.
Is that totally foreign to you?
No.
Okay? You say no? So you know what it is, Brian? Okay. The perfect square is the square of a whole number. The square of a whole number is called a perfect square. A while ago, when I said, I don't remember what number it was. I don't remember what number we had written on that. I think it was, in the beginning, we had 8, was it 8 to the second power?
Yeah. No, 8 to the fourth power.
Which one of them was it to the second power?
17.
17, okay. That says 17 squared, or 17 times 17, right?
Uh-huh.
Okay. You got a calculator? Do it. 17 times 17. Tell me what its value is.
289.
289. The number 289 is a perfect square. So, we got to go quickly. A perfect square, we're done. Never mind, they're lined up. We're stopping right there. We're going to talk more about perfect square tomorrow. Okay? We're stopping right there. I believe your voice needs to be turned off. I believe you go to voice off.